At a live demonstration for India's Army Day last week, the Indian military showed off a swarm of 75 drones destroying a variety of simulated targets in explosive kamikaze attacks for the first time. The commentary accompanying the demonstration claimed that the swarm is capable of autonomous operation. You can see a video of the event here. While the swarm's exact capabilities are not clear, the event is a clear indication of how the technology is developing and proliferating. The 75 drone swarm shows the current state of the art, but India's goal is a 1,000 drone swarm. Swarms of small drones have the potential to overwhelm air defenses, and their low cost means they can be deployed in far greater numbers than existing systems. While massed drones in spectacular light zones are all controlled centrally, in a true swarm each of the drones flies itself, following a simple set of rules to maintain formation and avoid collisions with algorithms derived from flocking birds. 1,000 drone swarm could hit a vast number of targets, enough for analyst Zach Callenborn, research affiliate at the Unconventional Weapons and Technology Division at the National Consortium for the Study of Terrorism and Responses to Terrorism, START, to argue that it would constitute a weapon of mass destruction. In the demonstration, scout drones investigated the targets, then mothership drones released explosive-laden kamikaze units which carried out the attacks. Callenborn noted several significant features of the demonstration. The Indian Army appears to be using three types of UAV, a quadcopter probably for sensing, a six-rotor mothership drone, and the small quadcopters with explosives on them, Callenborn told me. National security discourse in the United States around drones often emphasizes a large homogeneous swarm, but India's work shows this is a mistake. So far US efforts, like the PDX demonstration of a swarm of 103 air-launched drones, and DARPA's Gremlins swarm, have all used drone of a single type. A mix of drones with heavyweight carriers, reusable scouts with advanced sensors and expendable attack drones may be more flexible and capable. Callenborn also notes that the claim of an autonomous swarm is plausible, but it is not clear how much of this has been achieved so far. The question in my mind is how sophisticated the autonomous capabilities are, says Callenborn. The announcer notes in the beginning the drones are programmed to carry out these attacks. What's not clear is how well the system would function in actual combat environment where the drones will need to adapt to rapid changes, a complex environment, and mobile targets. Notably, the targets used in the demonstration were all stationary. While new technologies and in particular AI and edge computing will drive drone swarms, the key element is the swarming software. This has developed rapidly recently and is proliferating. AI now offer a drone swarm package for commercial users, allowing multiple drones to be controlled from a smartphone app. The most critical aspect is academic. How do you design algorithms to manage the increasing complexity of the swarm? In terms of both more drones and different types of drone, says Callenborn. The challenge with drone swarms comes from how the drones communicate and coordinate their actions, which is primarily a programming problem. India has been collaborating with the US to develop swarming drones since 2018 under the Defense Technology Trade Initiative, although few details have been released. According to the commentary, the drone swarm is capable of attacking targets from a range of 50 kilometers. In addition to reconnaissance and attack, Indian drone swarms will also be able to carry out resupply missions, with a 75 drone swarm delivering over 1,200 pounds of supplies to troops in the battle zone. India is also developing drone swarms that can be deployed from fast jets. A Jaguar strike aircraft will carry 4 pods each containing each of the air-launched flexible asset, swarm, or Alpha-S drones, which are capable of attacking air defenses. This project was fast-tracked last year in response to China's deployment for surface-to-air missiles across the Ladakh border. India is not the only country pursuing attack swarms. Last year China showed off a truck-mounted barrage swarm launcher capable of putting 48 attack drones into the air, and the Turkish military took delivery of 500 cargo kamikaze drones claimed to have swarming capability. Proliferation of basic swarming technology is inevitable, warns Callenborn. The likelihood of US forces encountering swarms is 100%. The question is not if, but when and where. Exactly how well the American military can deal with drone attacks is open to question. A new Pentagon strategy paper on counter-drone defense warns that previous hurried efforts have resulted in a patchwork of incompatible weapons and sensors, and that a coordinated approach is needed. The paper highlights drone swarms as a particular challenge for defenses. The Indian demonstration was a staged event and not an operational capability. But carrying out any sort of technology demonstration in front of a live audience is a risky business, especially with armed drones, and the fact that the Indian Army was confident enough to show off their swarm suggests it may not be long before such drones are used in action. First use may quite possibly in the border conflict with Pakistan. And, as elsewhere, they may prove to be a game changer.